Hello everyone, welcome to Code Enzyme, and in this video I will discuss the approach of this problem increasing subsequences. So basically we want to find the longest increasing subsequence in big O of n log n time because the constraints are 2 into 10 to the power 5. And actually I had solved this problem before, and today I was trying to revise the problem, and something happened and I actually forgot how I solved it before, and I tried to come up with a completely new approach. So I solved it using coordinate compression, and which is also a big O of n square solution, and then I kind of optimized it using segment trees to an n log n type solution. So in this video I will first discuss the big O of n square approach, which is the standard one using dynamic programming, and then I will move to a coordinate compression approach, which is also a dynamic programming approach, and then I will optimize it to an n log n time complexity. Yeah. So before starting this video, I would like you to hit that like and subscribe button because majority of my viewers have not subscribed to my channel, and it doesn't cost you anything, but it will help me a lot. So thank you. And now let's first read the problem statement. You are given an array containing n integers. Your task is to determine the longest increasing subsequence in the array. And the first line contains an integer n, and then there are n integers x1, x2 till xn. And let's see the sample input. So we have 8, 7, 3, 5, 3, 6, 9 to 8. Yeah. So we have this array, and the longest increase subsequence, like we can't start with 7, otherwise we can only go till 9, right? So we will start with 3. So my first element is 3, then I can select 5, then I can go to 6, and then I can either select 8 or 9. So let's say 9, and the longest increasing subsequence is 4. So this is our longest increasing subsequence. Or I can even select 3, 5, 6 and 8. Both of them will give us an answer of 4, right? This is my first solution, and we want to try to solve this using dynamic programming, right? And whenever we are solving a dynamic programming question, we should first define what our subproblem is. And let's say dp of I represents the LIS, longest increasing subsequence, of a of prefix of I, right? So let's say 0 to I, and if we can solve for all this all the dp of I, my answer will be dp of n, right? Because n is the length of the array, assuming. Now how can I solve this? Like what are my transition states? Now dp of I can be defined as simply maximum of dp of j plus 1 given that aj is less than a of I, right? I mean, if there is a j index which is less than and j is obviously less than I, right? So these are the two conditions. Like if I can find a j index which is less than I and a of j is less than a of I, then this a of I can extend the subsequence which is ending at a of j, right? Now let's try to code this up. So this is a big O of n square type solution. So this is pure dp. Okay. Now if I want to code this up, so I can say, okay, let's first take the integer input. Right. Now like okay, vector int a of n. Then let's take the array input. Then I have to say, okay, I can say make a dp array of size n and 0, okay, for I, for j in range less than I, and then I have to say, okay, whenever I have a of j less than a of I, so if my a of j is less than a of I, then I can say dp of I is equals to maximum of dp of I comma dp of j plus 1, and my answer is simply in dp of n, actually n minus 1, sorry about that, because my array is 0 indexed. So this will pass this, actually I got a 3, I don't know why. That is because this should be 1 here. Sorry about that. My default value of dp should be 1, not 0, because at least there will be a subsequence of length 1, right? Okay, so now we have this basic solution. It runs in big O of n square, and I was trying to optimize it. Now, if we want to optimize it, I have to n log n. I have to somehow query this loop in big O of log n time, right? Like I want to I want to make this query, this whole query, and which is a big O of n time query, and I want to reduce this to big O of log n time to make my solution work in n log n time, right? And this was I could not come up with it when I was solving it, so I tried to find another solution for this dynamic programming. So let's say solution 2, and in the solution I used coordinate compression. And this will also be a big O of n square solution. So now I will explain you what coordinate compression is. So if you are already familiar with it, you can actually skip ahead. Okay. Now, so what is coordinate compression? Now coordinate compression is technique used when the length of array is less. So I can say the length of A means array, is less, and the range of A of I is high, is very high. Like let's say A of I is going from 0 to 10 to the power 12, and the length of array n is only in the order of 10 to the power 5 or 10 to the power 4. Then I can say by pigeonhole principle, there will only be unique at most 10 to the power 5 elements, right? So I can actually replace by my minimum element to 1. I can assign, let's say if my answer for 1, 2, 3 is same as the answer for 10 to the power 5, 10 to the power 5 plus 1, 10 to the power 5 plus 2, right? So I can actually say, like, whenever I encounter in my array, whenever I encounter 10 to the power 5, I will replace it by 1. Whenever I encounter this number, I will replace it by 2. And whenever I encounter this number, I will replace it by 3. So my answer will actually reduce. Like let's say if if I have an array like 7, 9 and 20, if this is my array, then I can actually replace it by which is my smallest number, 7, right? So I will replace it by 2. Second smallest number is 9, and third smallest number is 20, right? So sorry about that. I will replace it by 2, and whenever I see 20, I will replace it by 3. So this is actually coordinate compression, and it is widely used in competitive programming. So right now I just wanted to explain you what coordinate compression is in layman language. And also, if the numbers are repeating, like if we have something like 7, 9, 7, 8, 9, then this array will become what is my lowest number? 7 is, right? Then the second 9 is the third smallest, so 1, 2 and 1. So when I coordinate compress this array, it will become this. So this is what I mean by coordinate compression. And now let's get back to the solution. So now that you know what coordinate compression is, what I realized was, if I coordinate compress my array and try to do the same thing, my answer will not change. So the observation is, answer does not change for coordinate compressed array. So I have an array, let's say let's say I have an array like 3, 1, 2, 4, 5. Okay, if I have I have this array, so clearly the answer is 1, 2, 4, 5, right? And if I increase every element by, let's say 100, so this will become 103, 101, 103, 103, 101, 102, 104 and 105. Now my actual LIS will obviously change, but the length of the LIS will not change. It will still be 4. Like if I coordinate compress this, I will still get my answer as this only. So what I did, I actually coordinate compress the array. So let's first do that. So how do we coordinate compress an array? Now we want to assign something, right? So I will make a map of intent and let's call it m. Then I will say m of a of I plus plus. So all the unique values of a of I will be stored as indexes of this map, right? Then let's say int c equals to 0, and for auto and x in m, x dot second equals to plus plus c. Yeah. So we have this. Using this, I can say, since my map is actually sorted in C++, I can say the smallest element will be assigned a value of 1, then the second smallest will be assigned value of 2, and like that. And now I can replace every element in the array. So I can say for I, a of I is equals to m of a of I. Now even if I do this, my answer will not change. Like you can see, okay, the time increased a bit, but my answer does not actually change. So I coordinate compressed my whole array and did the same thing. The answer did not change, right? Now what else can we do here? Like what is the need? Like how does this coordinate compression actually help us? So if I have something like 3, let's say 1, 2 and 4, right? Then let's say now I know my maximum number is 4 here. So I can make a value, an array of 4 integers. Let's say 0, 1, 2, 3 and 4. So initially everything is 0. So 0, 0, 0, 0, 0, 0. Okay, let's say I am at the first index. Now I will ask myself, like how many in this array, the array of 5 elements or 4 elements that I created, actually it should be 4 elements. Is there a number which is less than 3? So I am querying in this range 0 to 2. What is the maximum element in this? It is 0, right? So I will say, okay, I will extend the maximum element in this range by 1. So let me take a smaller eraser and I will say 1. Okay. Then I will move this pointer to here and 1. So I will ask myself that what is in this range from 0 to 0. Like in this range, actually, what is the maximum element? It is 0, right? So I will increase my answer by 1 for this here. And then I get a 2, right? Now I will ask myself, like, what is the, for this index, what is the maximum element in this range? It is 1. So I will increase the subsequence that was ending at 1 by 1. So now my LIS for this index becomes 2, right? And now when I reach at 4, I will ask myself, like, what is the index, maximum index, which is ending at either 0, 1, 2 or 3, right? So in this whole array it was 2, right? So I will increase my length by 1, so it is 1, it becomes 3. And then for the final answer, when I reach at the end, I can just query the maximum element in this whole new array. So the answer is simply 3. Now why is this working? Like if I am asking what are the number of elements which is less than in the range 0, 1 and 2 in this, since I'm going left to right, every element in this range will obviously be smaller in this range will obviously be smaller than 4, and since I'm going left to right, the array is only processed for the first I elements. So it is actually very similar to the previous solution that we had here, but just we had used coordinate compression for this. And why is this helping? Like how is this even beneficial? Now you will realize something, that we are only querying the prefixes. So we can probably use something like segment trees to query this maximum in the in this prefix in big O of log n time, right? And this length of the array is obviously will less than 2 into 10 to the power 5. So I can easily make a segment tree out of this and try to solve this problem. So rest is the very simple implementation of this whole thing. So if you want to do it with me, get ready. Now we will try to code this up very quickly. Yeah. Okay, so we want to update this code, right? So first I will make a tree array because okay, so let's remove everything here. Now I want to create a segment tree, right? So vector int tree, and let's say a size variable, the size of this tree. So I can say okay, uh, so this has all the unique elements, so I have to make a power of 2. So my segment tree will be a power of 2. So I can say while sz less than c plus 1, sz is equals to sz times 2. Now I will resize my tree array. Sorry about that. So I will resize my tree array to 2 times of this size. Now since I don't actually have to initialize it, I will not write the build code for this. Now I will simply start querying. So for I, now what will be the answer? Answer will simply be 1 plus query of. Now I will have to write this query function. So let's say int query, int low, int high, and let's say the current node which will be 1. Then we have the node left and node right. So node low and node high. This will be initialized to sz minus 1 and node low will be equal to 1. Now why node low is 1? Because we don't want to consider the zeroth element, 0 as the element, because my a of I is actually going from 1 to 10 to the power 9 and not 0 to 10 to the power 9. Okay, so I just decided to skip it for now. Okay, so why are we getting an error? Okay, so I am querying from 1 to a of I minus 1. So this will give me the maximum element in the range 1, starting from 1 to a of I minus 1. So one element before, like we were from when we were querying from for 4, we wanted to find the maximum element in the range 1 to 4 actually. Sorry, 1 to 3, right? So that is why I am querying that. Now what can I do? Like first I have to first I will handle some base cases, like okay, if low is less than high, then I don't have to do anything. If this is completely disjoint, so if my low is actually greater than node high, I by mistake wrote a t here. Okay, so node high, and then or my high is actually less than node low, then I will simply return a 0. There is no point in querying anything here. It is completely disjoint. Else I can say if it is actually completely inside. So if my low is actually if my low is lower than the node low and my high is actually more than node high, so node high, then I have to simply return the tree node, right? Else I can do else what can I do? I have to calculate the mid index. So node low plus node high by 2. Now once I have this, I can simply return the maximum of these elements. So query, what do I need to query? First thing I need, let's say int answer equals to, just to tidy up the code, so low high will remain the same. Then I will go to 2 times node and node low to mid, and then my answer will simply be the maximum of these, right? So max answer comma, now what will change here? We will get a +1 here. We will go from mid +1 to node high. So this is the code, and then I will have to return the answer. Yeah, so this is the query function, and once we are queried this, I have to update my tree, right? So to update the segment tree, I have an index j that I am currently at, which is equals to size plus a of I minus 1, and then I will update the value. So this is the index in the segment tree, in this array that I have to update. So I will simply update my tree of j is equals to x. So this is the new updated thing. Like whenever I was querying like 3, so I have to update that the index at 2 is changing, right? So I'm doing that. Then j is equals to j by 2, and while j is greater than 0, I can say tree of j is equals to maximum of tree 2 times j comma tree 2 times j plus 1. Okay, and j is equals to j by 2. So this should update the tree, and then I have to query for the maximum. So I can say the tree of 1 will contain the maximum element of everything, right? So now let's try to run this and see if it is working. So yeah, it passed the test case in 93 milliseconds, so it is already quite fast. Now let's try to submit this and see if it gives us a correct answer. So our solution got accepted, and if you were actually able to solve it and you have watched it till here, kindly like this video and subscribe to my channel. And I will see you guys next time. If you have any other doubts or you want me to make a solution video on some other topic or problem, you can comment down this video, and I will see you guys next time. Thank you.